I'll give you a second to write stuff down. Oh, this sucks. I want my water.
Are you recording it?
Mm-hmm. As long as people ask me, I will record them. But sometimes people don't ask, so I forget to record. Okay. So, you're naming aldehydes and ketones. I guess down here, I'm gonna quickly do the priorities. Right, so we have aldehydes, ketones, alcohols, thiols, it's like double bond, triple, and then it's like alkane, or alkyl groups, and then halides. So this is the pretty much comprehensive list. And so when we're naming, all this list means is that this becomes number one, or the lowest number. If you only have alcohols as your highest, you don't have to worry about what's above it, it's not on the molecule. But now, since we're in this unit, these guys will always be named first. And I think the only thing that outranks them is carboxylic acids. So, which you guys will learn about later. So, this will be the list for now. So just a quick review. This is an aldehyde. And this is a ketone. Both of these can do the acetal and hemiacetal reactions. I know she brought those up in the videos too, right? This double bond is pretty important. And so if we were to name this 2, 3, 4, butanal. If you want, you can put one butanal, but it's redundant because the aldehyde is always going to be number one because it's always on the end. Ketones can be sandwiched, the aldehydes are always on the end. So, butanal. This one, same thing, except this time you do have to put a number, so the ketone's on 2, it would be 2. Pentanone. Any questions about those? I know.
Did you say pentanal?
Or pentanone.
Okay.
Pentanone. I said pentanal. I
Yeah.
meant pentanal.
And you
I
do
wrote it.
penton too, right?
Yep.
Okay.
So, which is what you can tell why sandwiching them gets more efficient as you have more things added on. So it's good to get into this habit. Didn't she say they were getting rid of this too? Possibly. Whatever. She mentioned it one time and I was like, that's weird. It's never been like that, but okay. Anyways, so here. I'm gonna start here because again, we're prioritizing this, even though this double bond could be 1, you start here. So 1, 2, 3, 4, 5, 6. So this double bond cannot be cis or trans. Because it has the same as 2 hydrogens on the one side. So they can't point in opposite directions. So you won't need to put cis or trans. This is one of the few exceptions. So then we have 4,5 methyl dimethyl.
Can you repeat why we're not doing sister trans?
Yeah, so double bonds, if it's like this, it's
Yeah.
trans because on each of the sides,
There's an H.
they're different, right? So this one, if you look at it, there's just 2 H's on the end and then the rest. So since these are the same, you can't pick which one's the winner. So these are obviously going in different directions. If this were, they're pointing the same way. I think if you put cis or trans, she would mark you, she would take points off for this one. Yeah, so be careful, be careful. So 4,5 dimethyl. And then this has 6. So this is hex. I'm gonna do 5 ene, or you put the E there, it really doesn't matter. 2 ohm. Or 5 hex ene 2 ohm, if you prefer that way. Any questions about that? So this one here, I put it up here because she loves to trick people, because people forget what an alcohol is called. So it's very easy to remember because it has hydroxy. Hydrogen, oxygen, it's a hydroxy group. And again, we'd start numbering here anyways because it's an aldehyde. But if it was like a ketone or something, still label this way because alcohols are down beta. So 1, 2, 3, 4, 3 hydroxy, and then butanal. Sorry, I've only given butanals. That's my bad. Any questions about these ones? So this one right here, this is a cyclo. We're always going to start numbering at the carbonyl. And so if I were to count, I'm going to go this way because this will give me the lowest numbering because the methyl and the bromine have the same priority. 5, 6. So this is 2 bromo, 5 methyl, 6-hexanone. Now,
Known as the suffix for the
ketone.
carbonyl. Yeah,
Yep.
ketones, right?
Are you good? So it's a carbonyl.
Carbonyl.
Yeah,
That's what I was
like
going to say.
this is a
yeah.
carbonyl. This is a ketone.
Ketone,
Does that make
as a
sense?
whole,
Yeah.
yeah.
It's like the square and rectangle thing.
Yeah.
And again, for this one, since it's on a ring, it's always assumed this will be number 1. You do not have to put a 1. So this is when the ketones could be like the aldehydes and automatically get 1. And if you put a 1 here, then she's not going to dock you. That's an instance where she's not going to dock you for having more. I have this one. Again, if I'm going to number 1, 2, 3, 4, 5. This is trans. So trans goes in front. And then this is a isopropyl. And then this is a ethyl. So it's trans, 2-ethyl, 4-isopropyl, cyclohexane. Any questions about that? So she's probably gonna have a question that'll have like 3 different things to name or to draw. Yeah, go on ahead. And I will give more examples at the end too. I'm gonna erase it. Well, I don't have to erase it to make this point. So something that was on the worksheet and she may have you do is draw a dipole, right? These have electronegativity, which makes it polar. So how you would draw the dipole, the negative electrons are pulling up all of that electron mass up and away from the carbon that's down here. The rest of this is all nonpolar, so I guess if you really, it would just be like a straight line up through it for the big one. If we were to do something like this, anybody know if bromine is more electronegative than oxygen? I feel like, I know. Because what it is, it's like, so they're both like tied. So I don't know which one. For now, we're just
Between
gonna,
the two?
yeah, we're gonna say it's gonna split, but anyways. So dipole here. There's a dipole here as well. The rest of this, nonpolar. So the dipole would just go through the center. And because I do not know which one is more electronegative, because that's not super clear, they're literally competing. So.
When I looked at it, they're pretty like similar on like.
Oh, and like the color. Yeah. If I had to say,
I feel like it would be bromine.
I think it's this.
Yeah.
Yes.
But this is like, what gets me is like this is more reactive. So technically,
Yeah.
be like this. And then these, this one right here, this would be super weird. I don't know if she'd give me this one, but draw this. Also the dipole here. There's the dipole here.
Yeah, no.
And then, I don't know, I guess up. She wouldn't give you one like this. This one would be kind of crazy to do it, the big one. But you could label the individual dipoles. So any questions about polarity? Now we're gonna draw some sugars. We'll do a cyclic hemiacetal one to like warm up, and then we'll do the Fisher projection. So the Fisher projections, they're not difficult as long as you memorize the pattern. It's just there's so much you have to know with it. And so if you can memorize it down to a science, you'll be good because it's the same like problem solving process every single time. But it's important to not forget the different steps. And this eraser is ass. So, like, actually, it's okay. So, just to review, we'll make a cyclic hemiacetal. 2, 3, 4, 5. Do you guys see why I put the circle in the particular place now? Okay.
Wait, isn't this supposed to be an oxygen?
Yeah, it's an oxygen.
Oh, you said circle. That's why I was confused.
Oh, I know. I know. I mean, it technically
It's
is
like
a circle.
circle.
Yes, oxygen is circle. We also have a methyl. And then on 1, 2, 3, 4, 5. So this one's pretty easy. But what she was doing in introducing this is showing you how you can take something that's linear and then make it into a ring. So we'll start, I'm just gonna draw one off the dome. Remember, all of them are gonna be D sugars. We'll start easy with an aldehyde up there. So, this is also a cyclic hemiacetal, and it will turn into a ring. And they are constantly moving between the states unless you can fix them in one of the states by using like oxidation reactions or like hemiacetal reactions. So, fill that in. I guess we can just start numbering. 6, 5, 4, 3, 2, 1. I go backwards, which is vaguely weird, but it makes sense to me that like the bottom one is 6 and the bottom one is not 1. So if you want to number it differently, you can. It'll just be opposite of me. Alright. So this is 6, 5, 4, 3, 2, 1. I'm setting it up the same every single time. There's 6, 6. I haven't even done anything else.
Is it important which way you number? As in, like, if it was the opposite, like 1, 2, 3.
Oh, no. So as long, right, as this is 6 or 1, right? Because if you start 1 down here.
Or, like, even if you went, like, where the 1 is.
Oh, so if I numbered this way.
Yeah. Like 5, 4, 3.
So, no, but it's going to impact where, like,
Where
the CH2OH is.
Okay.
Right? You
Yeah.
kind of want them, like, you can do it a different way,
Uh-huh.
but it may be easier because she will always do it this way.
Okay.
Yeah. And I will always do it this way. So you can. It would just be more difficult.
Okay.
Yeah. If you're trying to constantly in class,
Yeah.
like trying to translate. But regardless. So you have the 0, and then I don't know why I erased that. These are all gonna be ups and downs. The CH2OH, if it is a D sugar, is gonna be up top. And the other thing attached to that carbon, right, because this is carbon number 5, it has a CH2OH, it has the H, and it has the O, which is here. And so if you keep moving up, you get to these. And so basically, if it's on the right side, when you're putting the OH, it's gonna go down. If it's on the left side, it's gonna go up. The way that I remember it is counterintuitively, because I'm right-handed, and so I think right should go up.
What you repeat what you just said.
Oh, so when you're making these sugars, we're gonna be putting OHs on, right? Because that's what's attached. So the direction they go, because they can go either up, like this, or they can go down. So if they're on the right side, they're always gonna be pointing down. So this is a bad example. We can go to 3. So 3 is down, because it's on the right. And then the H would be up. This one is on the left, which means it's gonna be pointing up. And the reason why this is important is because if it's on the left side, it's pointing up, it's the same direction as the CH2OH. So if you were to swap these, like, she would mark you wrong, because this is basically cis-trans extreme. Yeah, I know. So, numbering is important, so you know, and then making sure whether things are cis or trans to each other. And we'll do plenty more of these. We will do thousands of examples. So, 2, also on the right, that means it's going down. So, for this last one, this one is special, right? Because this carbon, this like pops up, and this becomes the OH on this one. This is the anomeric carbon. I don't know if she introduced that term in the video or not, but this carbon is super important because it's attached to the aldehyde, and the aldehyde can be oxidized and reduced. So it's very important, this one. This is where everything is going to react. So if let me make a list. So we have number of carbons in the ring. The second thing you have to get right is the up, down. And then the third thing is alpha or beta. And so alpha and beta is indicating whether this final OH is going to be pointing in the same direction as the CH2OH or in a different direction. And so this one is also, in my opinion, counterintuitive, because I think alpha should be up. In my head, that's what I associate it with. But I know that's wrong, and so that's why I remember, because it's not that. Beta will have the OH up. So this would be beta, insert sugar name here. Now if it were to be alpha, I'm just gonna draw in like a zoomed in thing. If it were alpha, this OH would be down. And so beta means that the CH2OH and the OH are pointing in the same direction. So this means cis. And then the beta is where the OH, I'll just do like OH versus CH2OH, so you guys remember. And this is important because when we get past the point of drawing these, she's gonna start moving all of these numbers that you know and love around. And she'll be flipping them in every direction, just in like pictures. So it's important that beta, cis, because sometimes this can be this carbon, and that just means everything is like shifted. Yeah. So that's an important point. Any questions about this? I know this, again, first example, it's a lot.
How do you determine alpha versus beta for the top though? So if, as long as the oxygen's over the sugar, or?
Oh, for this?
Yeah.
So this right here, this cannot be alpha or beta.
Yeah.
Yeah. And so she will tell you, draw alpha, da 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 da, and
Oh,
give you the
okay.
Fisher projection.
And then
yeah.
she'll tell us to make it
Oh,
alpha.
okay.
Okay.
Fell out. Yeah. So she will give you the Fisher projection, and she will say, draw alpha or beta, blah, 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 blah.
Okay.
Yeah. And so basically what happens is, this is beta right here. It can go back to this, and then it can go over to alpha. And so they'll go back and forth, unless you can make this hemiacetal into an acetal. And so one thing she may ask you is how to stop this sugar from reacting. Because this sugar right here is a reducing sugar, which means that it can still interact. It's not fully to the acetal form yet. And so, if you wanted to make this into an acetal, I'm going to use the alpha one down here since there's more space. You could just throw on HOME, and it would replace the OH. This is a hemi, and this is an acetal. So again, a lot of moving parts. So that's why we're going to do a bunch of examples. But once you get all the parts down, it's not that bad because it's the same for every single question. Just the formula getting it down. Just to hit this point home, if I were to react this with, like, let's say Benedict's, no reaction. If I were to do this with Benedict's, it would do insert, I'm just gonna write yes reaction. Because it would make it into a carboxylic acid in this form. It would basically take it out of this form and make it back into this, into this COH, the carboxylic acid.
So why is adding the Benedict's making no reaction for the acetal?
So the Benedict's, with this, it's the hemi, which is constantly going back and forth. You remember with, I can just draw like a basic one. Let's do HOET. OH, OET, and then you have OET, OET. Basically what's happening is these can go back and forth. They live in equilibrium. You have to really hit this one home to get it to not react. And so the reason why this one can react is because it's still in this stage where it's going back. Yeah. So it'll get kicked out into this, and then this will oxidize because it's aldehyde specific into this. That's why none of these other OHs are impacted by the Benedicts, right? It's literally just changing this because it's aldehyde specific. It doesn't attack the alcohols and oxidize them. I know.
Yeah.
It's a lot. So we'll do more. We're gonna do a 5-ring example, and then I'll do the same exact thing. Okay. Am I good to erase this? Okay. I'm gonna leave my checklist up there. And I'll leave the hemiacetal up there. So this one, again, it's always a D sugar. We'll just do, I think this is ribose. Well, I don't know what's up top. So if the top is the same, then it's ribose. But you have this. And she would be like, draw alpha, beta of this. And so, right, we got the double arrow. It's going back and forth. If I draw it upside down, maybe that's like, maybe that'll help your brain. So again, it's the same base every single time. I know it's going to be 5 carbons. It's the same setup. We'll make this one alpha. I'll just put that over there. Any questions about this part? We're good. So number 4 has the CH2OH. Remember to always point it up because it's D sugar. And then we go to 3. It's on the right side. And if it's right, then it's down. And this one's also down. And so we've got the number of carbons on the ring, and we've done the up, up, down. Next we do alpha or beta. This one is alpha. And so it's gonna be trans. It's gonna be pointing down from the CH2OH. So you have your OH here, H up there. And I'm gonna star it again, just so we know that's the anomeric carbon. You guys have any questions? We can just keep doing practice, but. And so, since these two are going back and forth, if I were to react this, we use the, what was it, Tollens? We'll use Tollens. If it's in this hemiacetal form, or the aldehyde form, that'll react. However, just like the hemiacetals, I'm gonna put HOPR just to mix it up. And this alcohol is now OPR and H. Mm-hmm.
I have a question. What was the special carbon called? I wanted to start on it right now.
Oh, the anomeric carbon.
How do we determine where the OH goes?
Or the what?
How do we determine if the OH goes down or out again?
Oh, so if it's cis to the CH2OH, then it's beta. If it is trans, it is alpha. So cis, trans. And this is what you're filling in yourself. You're not looking to here to get the up down. This is you from like the cue of the question, draw alpha, draw beta.
Oh, okay. So she'll tell you if it's alpha or beta.
Yep. So
Oh, you wouldn't know if it's alpha or beta just by looking at this. You have to draw it that way.
Just to tell you, yeah.
And then for the anomeric carbon, is that the one where she's like, if it's on the right, it's heavy sugar type thing, or?
So that's this one.
Yeah.
That's the anomeric carbon is this one.
Oh.
It's
okay.
my number 1.
Okay.
Yeah.
Okay.
And so that's why, right, we've done our acetal reactions with the carbonyl. That's why that's important, because that can react.
Okay.
Yeah. This one is just the one that gets sandwiched.
So that was what it would look like if it was beta.
This is alpha,
Alpha.
because they're going up and then
Yeah.
down. If it was beta, it would
Okay.
look like that. So to finish this thought, because I kind of left it hanging, now that it is an ether and it cannot go back to this form, it cannot be an aldehyde anymore. If you were to react it with Tollens, it would be a reaction. And so I guess I forgot to mention the last time, when you make it this type of sugar, this is a non-reducing sugar. Even though it's technically being oxidized, that's what they call it. So this can still reduce and oxidize. So this is reducing. This is cured, it is now non-reducing. I'm gonna just slap another one up so we can just keep. It's just doing the same thing over and over again because that's all these questions are. Which is nice. Again, there's a pattern. All right, am I good? Also, can somebody do a time check?
7:32.
7:32. Okay, perfect. And there wasn't anything else. It was just the Zoom. Also, thank you for talking. That was super cool. Oh my gosh. I had no clue. I was like, whoa, surprise speaker.
Yeah, he emailed me like the day before.
She must have like tipped him off or something.
Maybe. Yeah.
Unless she's too busy with the baby.
Yeah.
She literally, what was it? It was the day after the Zoom. She didn't even ask how it was first. She just sent me the baby photos. and then was like, oh, how did class go? I was like, thanks. But the baby's cute. Cute baby. Cute kid. Anyways. Now, because I'm not nice, I have to, I know.
Come on. You could be nicer than her.
I know. I'm making it a ketone. That's all I'm doing. So instead of an aldehyde, it is now ketone.
For what?
For what? Because this is what she will pull.
I know.
I have to prepare the troops.
I know she will.
Is the only Fisher projection to know glucose?
Yeah.
Can we put that up as well again?
Mm-hmm.
Okay.
Let's see if I can remember.
Second one is H on the right. It's OH, OH, H, OH.
Because I was not here that day.
OH?
OH,
H.
OH.
Okay, perfect. You guys know better than me. Because I don't have to have it memorized for the test. No, that looks, I knew one of them.
Yeah.
I knew there was a break somewhere. This looks right. If it's wrong, then,
Sorry.
yeah, well, no. Just kidding. That should be it.
Here, let me just bite the bullet for y'all.
But anyways. Did I just do this one? Did I make up the same combination? Just make sure that I
No.
didn't. Okay, it's a different one, okay. Again, they all look very similar, which is why these questions, like, they're ass, yes. Because they can be so different and you can get points off even though they all look the same.
They all look the same.
Am I good to erase glucose so
Yeah.
I can use it to, okay, perfect. And that's all, she won't, she may ask you, this would be crazy of her, she could ask you to draw like alpha or beta glucose.
She did on last year's exam.
Okay,
Yeah.
so I'm actually gonna rewrite it in down here, so we can do that one next.
Okay.
She did on last year's exam.
Yeah.
I distinctly remember that.
Because what she could do, because you guys know glucose, she'd just be like,
She's
draw
gonna be
beta
like,
glucose. And she will not give you the Fisher, because you're supposed to know
Nope.
glucose. Yeah. That's what I mean.
Has
Like,
you she had you draw the Fisher earlier in it, and then it was like the last question. She was like, draw beta, and I'm like, oh, you no.
please, no.
No.
Please, no. But anyways, here's tiny glucose, because we'll be using that later. Down here, it's CH2OH. Just a reminder, all of these are chiral. But you guys all know that. Maybe. I'm just kidding. I mean, nobody said, yeah, I know it. So, okay. Do you guys want to do alpha or beta? We can do beta. Or, oh, I'm being challenged. No? Okay. I don't, now I forget what I said and now I'm anxious.
You said beta.
Okay. I
I already wrote it down.
I'm like, guys, I got flustered. I got flustered and I forgot. Anyways. Again, it's the same base each time. Same formula. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. And we always start with the CH2OH. It's a D sugar. It's going to go up. Let me fill in the rest of these. This is on the left. Both of these are, which means that it goes up. So OH, OH. And that last one is on the right, which means it's down. Right. So this one is beta, which means it's going to be pointing in the same direction. It's going to be cis to the CH2OH. So the OH is just going to be up here. Now what's different is that instead of an aldehyde, right, that had an H here, and so this would what an aldehyde would look like. It's a ketone, and so you have to account for whatever is here. So it's just an ethyl, right? Yeah, 1, 2. If you wanted to be really fancy, but she's not gonna, for these types, she's not gonna like harp you if you write ethyl. Like, you know how with drawing, sometimes she usually wants you to draw the whole thing out? Because this is not focusing on whether you know what an ethyl is. You can put ET. You don't have to write it on. Okay. So, even though this is a ketone, this can still be reduced because it has this OH on it. It's a hemiacetal. So it's a hemiacetal and a reducing sugar. And if you wanted, I'm not going to go through the whole process again, but because that can oxidize, you can put in your alcohol and make it non-reducing.
It would be OME and then ethyl at the bottom, right?
Mm-hmm. Yep.
Wait, what was it?
Oh,
It's
so
OME on
OME on
place of
top.
the
Yep.
OH?
Yeah.
it would look like this. I just didn't want to draw the whole thing out again.
No, you're fine.
So, non-reducing anymore. Oh, and this is a fun question. How do you get it to go back?
No.
Water and acid.
Yeah, water and acid. I know. Here's a really fun question.
That's a crazy statement.
I know.
No.
I know. It's literally heresy, but she will act like, I'm literally in Creaky's mind right now.
You
I-
are.
I'm literally in her
This
head
is-
right now.
This is some crap. Cool.
Because she hasn't been here, so I've absorbed her brain cells.
You've been hanging out with her too much.
No. Girl. No, I'm just kidding.
So does the OME always just take place where the OH is?
Yep.
Okay.
Yep. Because
It's
No
double
longer.
H and a- yeah.
All right. Any questions about this? We can do glucose. We'll do alpha. Oh, so if it still has the OH, if it can still react with like the oxidizer or reducer,
It's reducing.
it's reducing sugar. If it's protected, it no longer can reduce, non-reducing. This one, because she will probably have you guys do it, I will do both alpha and beta, so you can take a picture of both and have both in your notes. I'm gonna start. So we have this. I know it's 6, so I'm gonna draw them. And on both sides. That one's terrible, but. So what's nice about these is they're going to be exactly the same until you get to this carbon. So let me I'm gonna set them up. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. 6, 5, 4. Okay. Everybody good with the setup? So, this is on the right floor, so it is down. Left is 3, so up. And then 2 is right, so down. Oh, and I forgot the CH2OH. Arguably the easiest thing, 'cause it's the same in every single problem. And then I'm just gonna fill in the same on the other side. So if it is alpha, the OH on the anomeric carbon is going to be trans. So if this is pointing up, alpha will have the OH pointing down, and it's an aldehyde, and so this up here is just the H. And then over here, beta is cis, and so the OH is going to be up, and H will be down. And that is how you would draw alpha and beta glucose, D-glucose, because it's D-sugar. You guys have any questions about this? I know I kind of go through them fast because it's like the same pattern. That's how it is.
So when you, I don't know if you're gonna talk about this yet, but
Mhm.
the for the pentose and
Oh, yeah.
when she's naming them, the furnos and the do we have to know those?
Oh.
The furnos and the no. She said it in English. What is it? Anyway, I'm guessing it's because it's something like this. Oh, for the function first, 500 grams. Oh, I think here it says it's 6.
Oh. And so you're taking, like if this was glucose,
Uh-huh.
Yeah, because this is new. She's never made people
Mhm.
go this far before. So it would be like the gluco, Pyranos. And so you're just taking whatever sugar it is.
Uh-huh.
You don't have to name it like that, it's good.
So there is a chance what she'll do is she'll have like this one. I'll just redraw ribose. This is ribose. And she's like, draw the beta enantiomer and name it. That's what she could possibly say. So it would be beta D ribo. Yeah, that D is terrible. Beta D is a capital. And then ribo, what was it?
Like
Furnos.
Furnos for the 5-member.
Yeah.
So she would tell us it's ribose and be like, label, name it as. Okay.
That's the only thing I could see her doing it as, or possibly like a multiple choice. Like, what means 6-membered ring?
She does not do multiple choice.
Not. I know, she used to.
I know she did.
She used to. She's been, I don't know on you guys, but if she gives you something like that, like define the term or whatever.
Okay.
But I would not worry too much about it. Just a review for this. This is an Aldo Exos. And the difference is like this is the actual name, right? So glucose, the sugar would be named glucopyranos. I think so. If it was in the lecture, then yeah. Oh yeah, so you're gonna have a sugar. You have the prefix, so glucose, ribose. You have gluco, ribo. If it's a 6-membered ring, you add pyranos at the end. And so it would be, this would be beta D glucopyranos. Right, 'cause it's beta, you know it's a D sugar. This one, I think it is a lowercase d. Beta D ribo pyranos, 5-membered ring.
So ribose is when the O gets used on the same side.
Yeah, I just know this one off the top of my head. Yeah. I know it's a shell of ribose, but that's what it would look. I mean, that's all you have to memorize, like really, if you're trying to memorize these, it's just right or left. So, yeah, sorry, I did not. So that's
okay.
new. I just looked at the lecture slides and it must have slipped by me. So, jeez. So, only reason that you use this is because it's a ring. If she were to ask you to generally classify this sugar, aldohexose. This would be aldohexose. But not all aldopentoses are ribose. I think that's like the key. Like this is specific to the sugar. This is just categorization. What time is it now?
7:49.
7:49. Okay. Do we want to do another example? We can. Okay. We'll do another one. We'll make it 5-membered ring, so it's a little bit easier. And then I'll put up some practice too. I don't think you guys have much naming left, which is nice. Like conventional naming, that's different naming.
Yeah.
That's like, yeah. But conventional, as in learning more stuff, the only thing left is carboxylic acids. And they're just like aldehyde. Oh wait, no, there's ester. Oh,
Yeah.
I'm a liar. I'm a liar. But there's only one more set of things you have to learn.
Oh.
Yeah. After aldehydes
Only.
and ketones.
Only one.
Only one.
With a lot of.
With a lot of rules, but it's only one. Okay, really quickly. So I'm doing something funky. But I think she did a similar example in the slides. So this group right here, you do not need to know this yet, and that's one of the groups that I mentioned that's in like the acid family. This is an ester. It's different from an aldehyde and a ketone because it has that extra O on the end. Yeah. Beta or alpha?
Alpha.
Alpha. All right. So it's a 5-membered ring. Oh. And then I have 5, 4, 3, 5, 4, 3, 2, 1. It's the same start for all of them. The CH2OH is the D sugar, it points up. And then we keep moving upwards. So we have 3 and 2 are both on the left side, which means they're both up. Ah. Let me get rid of the 2 so you can see it better. And then since it is alpha, we are going to make it trans to the CH2OH. So it will be down. And I'll just start again. And the sugar is a reducing. I don't know the name of this one. We can name it like we would galactose. It's not actually galactose, but it'd be practicing naming for the, yeah, so,
Blank space.
Yeah. yeah. So we're gonna use galactose, but this is probably very wrong, so, end quotes. So this would be alpha D galacto, and then it would be 5, so it would be the furanose. It's a 5.
It's like
It's pyranose is 6, the furanose is 5. It's probably like, I don't know actually. I don't know how they got fur.
Yeah, she didn't.
Yeah,
mention that.
I have no clue, but there's probably some Latin meaning. Yeah, there's probably some Latin meaning, but this is what's different. This is just plugged in. Any questions about this one? Mm-hmm.
Sorry, is she gonna care if we do lowercase or capital T?
I don't think so, no. I was freaking out about it, but she does not care, yeah. I was just trying to do it like it would be presented in like a textbook, and I couldn't remember if it was uppercase or lowercase, but if you put it in uppercase or lowercase, she's gonna know what you mean.
Okay.
Yeah, it doesn't matter. Any other questions before I give some practice problems that you guys can take home?
I'll put the in
You're right, yeah. I forgot I did that. Yep. I forgot that I made it special. I've been on a big rant about it and then I forgot about it. So, OME. This looks like a hemiacetal, pretty much. Like you can, this looks like one.
Yeah. But you
It's
still
not as
need to
elusive as
reduce
the
it,
other
right?
one. Yeah, you still need to reduce it.
To make the OH.
The OH go away, no more OHs.
Yeah.
All right.
You said this was a tester, right? Is there gonna be?
No, you don't need to know that. That was my little sprinkle of enrichment. You'll need to know that within like the next 3 weeks, probably.
After the exam.
Yeah, after this exam, not for now. And I'll give some aldehydes and ketones. Is that too small?
Yeah.
Okay. just a reminder, just like the other substituents, if there's two of the same thing, it just gets a die in front of it in the ending. Then because I don't know sugar names, I'm just gonna write beta. You don't have to remember the furanose and pyranose, but since I do not have sugar names off the top of my head, you will just be drawing it.
Glucose, that's fine.
Yeah. You can do glucose.
Yeah.
Draw beta. Beta D. Glucose. And then, what's the name? So this is one that we already did, but just to reiterate it. And then
Reducing.
draw alpha. And I'm just gonna make one up.
Oh, you're so nice.
And if you want a second one. There's only so many combinations I can do of the same of the same molecules. We'll make it ribose with a twist. So here's some practice problems. Feel free to do them, send them to me to get checked. That's pretty much it. There wasn't too much other than this. This is just a multi-step process, which is why it seems like a lot. But this is all you have on the quiz. So it'll just be naming and then these horrible problems. Yep.
Review on Wednesday or?
Yep. Of course. I don't think she's gonna ask questions about the Zoom because she wasn't even in the Zoom.
Yeah, how does she expect? I'm sorry.
Yeah. Because I would be like, I know she typically asks questions, but unless she sat there and watched the recording.
The last one until like a month after it happened.
Oh, okay.
So she could just throw it at us randomly and ask one of us like some question offhand.
Which one
And
of your
she will throw it in
classes
there.
talked?
Which one?
This will be
What
a
was
test to
his-
see.
What was his name? I don't really know what you can ask.
Badge.
If you say Eli, you get like half credit. Because I guess he technically goes here. He's not in the class. He doesn't even go here. Alright. Yeah, see ya.
For number one, you would go with the double bond, right? Because it's
Yep,
part-
so
okay.
this, yep,
Okay.
that's why I did it, because I'm a trickster. I feel like I have to up my
No.
game. I have to up it. Oh. Right, so instead of going to the longest chain, you have to get the substituents that matter. Substituents that don't matter are anything that's not a methyl ethyl, yeah. So if this were, and let's say instead of this it were a bromine, you do the same thing. You have to get everything on the chain. Because these can just be reduced to ethyl, methyl. A bromine, it's,
Is this only for,
It's only for naming ketone and aldehyde.
yeah.
that's the thing?
Yeah.
Yeah.
So, we're naming 1 through 4, right? Or
Yep.
that's what we're.
Yep. And then these are just the, yeah. So that's like the practicing of naming.
Okay.
Thank you.
Of course. See you guys tomorrow.
See ya.